Okay, I wanted to do something a little different today and look at our trig identities for everything, all of our trig functions shifted by pi or 180 degrees and all of our supplementary angle formulas. And so this video is not really to derive these because these are all pretty easy to derive from angle sum, angle difference formulas. It's more that what I found was that sometimes I was forgetting which one to use, or I was maybe putting a minus sign in the wrong place, or I had to go back and derive it. So I wanted to see if I kind of had a better way to explain it and remember these. So to get started, what I want to do is I want to just look at these top four formulas right here because cosine and sine are so similar. Cosine and sine are just the same graph basically, but shifted. So I want to start with just these four here just because they're so similar. Sine is very similar to cosine just because it's the same thing. It's the same graph, just shifted. So we should be able to just look at this rough graph of sine, and whatever happens for sine is basically going to be true for cosine as well. So you're just looking at this graph. I just have our sine curve in blue. Here's our sine of x here. And then in red here, we have our shifted versions. We have sine of x plus pi and sine of x minus pi. They're the exact same curve, so I just needed one curve in red. And the relationship to notice between the red curve and the blue curve is it's just flipped. Like everything, if this point right here, let's say this is pi over 2 and this is 1, well, for the red curve, this point is minus 1. At any point, if you just look at the associated point, like if let's just say this was, if just say like this point here is like square root of 3 over 2, then this point here is going to be minus square root of 3 over 2. So coming up here to our values of sine of x plus pi and sine of x minus pi that we have on this graph, well, sine of x plus pi is just going to be the minus times sine of x, and then the same thing here, this is going to be minus sine of x. But now the same exact thing is going to be true here for cosine. This is going to be cosine of x plus pi is going to be just minus cosine of x. And then for cosine x minus pi, same thing, minus cosine of x. But next, what can we do to find these two values here for tangent? Well, tangent's just sine and cosine, so we can use what we just found in order to find these. And what we'll do is I'll kind of combine these together. I can write this as tan x plus or minus pi. Just because we saw here, it doesn't matter which way we go. We're shifting it 180. If we're shifting it by pi in either direction, it doesn't really matter. So we can get this for both formulas. But this is going to be sine of x plus or minus pi over cosine x plus or minus pi. But for this, using these two formulas here, we found this value is just minus sine of x. And then for this one, we found it was minus cosine of x. But then the minus signs are just going to cancel. We have sine x over cosine x, but that's just tan of x. So for each of these values in our table here, I can just write this in as tan of x and tan of x. So it's interesting. You shift tangent by 180 degrees in either direction, you just get back tangent. Okay, now here for our last three formulas, these are just the supplementary angle formulas that you may be familiar with, and we can figure each of these out from what we already did because, like for this first one, sine pi minus x is really similar. We can use this right here. So what I can do with sine, what I can do in order to use this, I can write sine pi minus x and just kind of reverse the sign on it. So I can actually write this as minus x minus pi. So if we put this in here and we write this in this form, sine minus x minus pi, then sine is an odd function, so I can basically just take this minus sign and bring it outside of the function. So when I do that, we can write this as minus sine x minus pi. So for this, we can just use this formula right here. We'll have our minus out front, and this becomes minus sine of x, but then minus times minus is plus, and so our formula for this is just going to be sine of x. Okay, next we want to find cosine pi minus x. I'll do really the same thing here, and what I can do, just rewriting it, we'll bring the minus out of it and change the order, write it as minus x minus pi. But now cosine's an even function, so this minus sign just goes away. And now we're just looking at this cosine x minus pi, which we already have a formula for, which is minus cosine of x. And so for that one, we'll just write in minus cosine of x for that supplementary angle formula. And then last for our value of tan pi minus x, we could do the same thing we did with sine because tangent is an odd function, so we could do it that way, but I think I'll just use what we found right here, and we can write this as sine pi minus x over cosine pi minus x. And we have those values right here. This is just going to be sine of x over minus cosine of x. But then just to make it clear, we'll just bring the minus right here. Sine x over cosine x is tan x, so this whole thing is going to be just minus tan of x. And so we'll fill that in, and that gives us all of our values in the table. But really my thinking on this is if you just kind of memorize these first four, but really it's just one concept that for sine and cosine, if we shift it in either direction by 180 degrees, we're just taking the minus of the function, just like we saw here. And then once we know these, it's really easy to find these. You can kind of do them in your head or write them out really quick like we did here. Okay, there you have it. Just a quick look at 9 useful trig identities. Thanks everyone for watching. Have a good day.